Okay, let me turn off my music. Sorry. Okay, so chapter 10, we're now talking about, we finished talking about surface area, and we've talked about 4 different shapes. We've talked about prisms, we've talked about cylinders, we've talked about pyramids, and we've talked about cones. And the reason why I wrote them in this order is because prisms and cylinders, remember, they're similar because they both have 2 congruent bases. So if I was drawing a rectangular prism, I have 2 bases that are congruent and parallel to each other, and it's a 3-dimensional figure. Cylinders, same principle. We have 2 bases that are congruent and parallel, and in this case, it's always going to be a circle. Pyramids are like prisms in that their base has to be a polygon rather than a circle. So let's say I have a square. Pyramids only have 1 base, and they from the base, all other sides come up and meet at 1 vertex. Cones are a lot like cylinders in that their base is always a circle, but they're also like pyramids because they only have 1 base, and then from there they all go and meet up at the vertex, at 1 vertex. Excuse me. So surface area. We've talked about how to find surface area of all of these 4 things. Remember, surface area is just the area of the base or bases plus the lateral area. And we've talked about the different formulas we have versus if we have 2 bases versus 1 base. Sometimes the lateral area will either be perimeter of the base times the height, or the lateral area will be, excuse me, for pyramids it would be half the perimeter of the base times the slant height. For cones, it would be perimeter of the base times the slant height, or pi r squared. Okay, so that's what we've talked about. Remember, surface area is like wrapping paper. Wrapping paper. Okay, that's talking about all the stuff outside. If we wanted to wrap a snow cone, how much wrapping paper would we need? If we needed to wrap a soda pop can, how much wrapping paper? If we wanted to wrap just a regular shoebox versus, if we wanted to wrap the Egyptian pyramids, what formulas would we use, and how much paper would we need? So surface area is like wrapping paper. And we are done with that stuff now. Now we're going to talk about volume. Remember, volume is not the wrapping paper. Volume is all the stuff inside. Excuse me. So volume is actually how much space goes inside this box or cylinder or cone or pyramid. To find volume, most of you guys think, oh, that's just length times width times height. And that only works for really a rectangular prism or a square prism, but now we have 3 and more different types of shapes that we're talking about. Think of volume as this. Let's say I want to talk about this box. Well, I can fit, this box is a present of paper. Yes, that's my paper. And I want to know how much paper can I fit in this box. That's volume. Well, here's 1 sheet of paper. Can I find the area of that 1 sheet of paper? Yeah, all I'd have to do would be base times height. Sweet. Or let's do length times width. In this case, that'll be a little bit easier. Go away. Length times width. Sweet. Okay, I'm going to zoom in on this so you can see my wonderful picture. Let's see if the writing goes with it. It kind of does. Okay, so here is my lovely picture, my lovely present of paper. Who wouldn't want a bunch of paper? Okay, so we said we could figure out the area of that 1 sheet of paper by just doing length times width. Now, how many papers can I stack in here? Well, I can keep going. I can stack on another sheet of paper right on top of it, and it would be the same, right? Length times width. And I'd go to another one, and I could stick it right on top of it, and it would have the same length and width, right? So the areas are just going to keep, I'm just going to keep adding up the areas until I can't squeeze any more paper into that box. And the number of papers that I can squeeze into the box, that's going to be my height. Okay, so to find volume, again, I don't want you to just memorize the formulas. I don't want you to be mindless monkeys here. You're going to understand the formulas. That volume is the area of 1 slice of this box. That's called the cross section. You're going to find the area of the cross section and then multiply that by the height. And that's going to be your volume. And this really, you can do a lot with this in calculus. You do some fun stuff with this. So if you took a cross section of a cylinder, what shape would it be? If you slice this can what shape would come out on the other side? It would be a circle. So for this one, you do pi r squared. That's the area of the cross section, and then you multiply it by the height of the whole can. Okay, so that's what we're doing today. For volume, we're talking about two specific figures, shapes. We're going to talk specifically about prisms, which is a little bit harder because remember these bases can be different shapes. Then we're going to talk about cylinders in the second video, which is easier because the cross section is always going to be a circle. Okay, so for prism, CP, you have this this worksheet with you. Where is it? Where is it? Here we go. All right, for CP, you guys have this. Today you're going to learn to find volume of prisms, and you know volume is all that space inside, and now we know what the difference between volume and surface area. Write it out because you might forget it. Okay, so volume, if you notice the shortcut, equals capital B times H. This capital B stands for the area of the base. You can think of it as the area of a cross section too. It doesn't matter to me if you talk about it as base or cross section. And remember, height is the distance between those two bases. Okay, so CP number 1 and 2 are the same for you, and you know what 3 and 4 are. Honors, I'll have to draw it for you guys. Okay, for number 1, rectangular prism. Again, I want you to highlight in what the base is. The first thing you're going to do is find the area of that base. Well, the shape is a rectangle. Easy. All you have to do is do base times height, or length times width. So that's going to be 3 times 13, and that's going to be 39. That's the base area. That's the first thing you're going to do. To find the volume, it's the base area times the height. So the height, remember, is the distance between these two bases. So what's the distance? It's going to be 5. So we're going to take 39, we're going to multiply it by 5, and that's going to be your surface area. I'm sorry, your volume. So 195 cubic centimeters. Whenever we're talking about volume, our units are in 3. Remember, area, our units are in squared, or 2. And for volume, it's always cubed. So that's a difference. That's one difference between volume and surface area. Okay, go ahead. I'm going to leave it to you to figure out what the surface area is. It may or may not be on a quiz tomorrow. And then for CP and honors, you guys are going to find the volume and surface area of number 2. Okay, so rectangular prisms are called such because their base are rectangles. Triangular prism, the shape of the base is going to be a triangle. So let me draw a wonderful triangular prism for you. Let me erase some of this stuff first. Okay, erase, boom, magic. Okay, so CP, again, you have this picture on here for you. For honors, I'm going to draw it for you. I'm going to draw it big over here, okay? So we have a triangular prism. That means the bases are going to be triangles. And remember, they're congruent and parallel, even though the way I draw it doesn't look like it. And then we connect all the vertices. Okay, so it kind of looks like a piece of pie. Yum. Okay, so we know, I'm going to tell you that this side of the triangle is 3, this side of the triangle is 6, and this side of the triangle is 8, but I'm going to write it down here so you don't get confused. And remember, these are congruent pieces. Okay, and then let's see. The height is going to be 5 miles. These are all miles. And let's see. This is not a right triangle. You know it's not a right triangle because if you try Pythagorean's theorem, it will not work. 3 squared plus 6 squared is not going to equal 8 squared. So I'm going to help you guys out. I'm going to tell you that the height of this triangle is going to be 1.9 miles. Okay. So remember, the bases are the shapes that are congruent and parallel, so it has to be the triangles. Okay, so these are the bases. The first thing you're going to do for volume is you're going to find the area of the base. So it's a triangle. You need to know, you know that the formula for area of triangle is base times height divided by 2. This is within the triangle, okay? It doesn't have anything to do with the height of the whole shape. So looking just in this triangle, the base and the height, remember, are always perpendicular. So which sides meet at right angles? Well, that would be 1.9 and 8. So that's going to be the base and the height of the triangle. 1.9 times 8 divided by 2. And that's going to be the base area. 1.9 times 8 divided by 2. Okay, so that one slice of this is 7.6 square miles long. Okay, so if you had a huge, this would be a huge present, in the shape of a slice of pizza or something. One slice of that pizza in that box is 7.6 square miles. Now you have to think, how many slices can you fit in this box? And the number of slices is determined by the height of the whole thing, and it's 5. So remember, for volume, you take the area of the base and you multiply it by the height, because that tells you how many slices you can fit in there. So you're going to take this 7.6, the area of the base, and multiply it by the height, which is 5. That has nothing to do with these ones. And that's going to get you the volume of your present, and the volume is 38 square miles. Cubic miles, excuse me, because volume's in cubes. Okay, so you will need this. I know we didn't use the 3 and 6 in here, but it will help you out when you find the surface area. Okay, and then compare. I want you guys to compare what the surface area answer is to the volume answer. Last question. This one is going to be a right triangular prism. So here's my right triangle. That's the base. This side's 6. This side's 10. So this side has to be 8 because it's Pythagorean triple. And look at how great my drawing skills are. Beautiful. Okay, so here's my other triangle is in the back. There's my other right triangle. I kind of goofed this one up. Okay, and then the height, remember, is the distance between the two. This is your height, and it's going to be 4 kilometers. So we're using units of kilometers, excuse me. Okay, so find the base area, find the volume, and then if you want to, find the surface area. Okay, so we talked about prisms. Remember, there's lots of different shapes of prisms. That we're just starting off with the basics, rectangular prisms and triangular prisms. We'll move on to some fun shapes like hexagonal prisms after the state test.